All right, guys, I'm going to quickly give you a basic overview of this second lesson, which is getting to know your tools, getting started with electricity. We're going to learn the basics of electricity. Electricity is a type of energy, much like heat, gravity, light. It flows through conductive materials like metal wire. Okay, you can convert electrical energy into other forms of energy to do something like turn on a light or make some noise with a speaker. All right, the components you might use to do this, like speakers or lights, are called electrical transducers. Transducers turn electrical energy into other types of energy like heat and light, and vice versa. Things that convert other forms of energy into electrical energy are called sensors, and things that convert electrical energy into other forms of energy are also called are actually sometimes called actuators, okay? As you can probably imagine, we use electricity in almost every single aspect of our lives. If you go ahead and click start stimulation here and you press and hold the button, you'll see the way that this works, okay? There you go. All right, so moving on, circuits are basically kind of our building blocks here, okay? Basically what a circuit does is it moves electricity through different components. Circuits are closed loops of wire, which you see here, with a power source like a battery and a component to do something useful with the energy called a load. In a circuit, electricity follows from the point of least resistance, or follows to a point of least resistance. So that means it goes to a point of higher potential energy, usually here from the positive side, to a point of lower potential energy, often known as the ground, okay, which is the lowest point of energy in any circuit that you're building. When the current only flows in one direction, that is called a direct current or DC current. In an alternating current, the current can change directions multiple times, like 50, 60 times in a second. And that's the type of current we have in our wall switches. So just to give you a visual of how the current flows, here's your positive side, right, or your anode, and it is flowing from here to the negative side. It just keeps going, and that's your loop, okay? Positive to negative, positive to negative. All right? So let's talk about some major things that we need to know in electricity to understand what's going on. Current, voltage, and resistance, okay? If you want to imagine current, there's actually a pretty good picture here, okay? If you want to imagine current, this is kind of a metaphor. The current is like the rocks coming down the hill, okay? And I'm just going to go up here and kind of show this to you. Imagine that there's a rock slide going down the cliff. As you can see in the picture here, the higher the cliff, the more energy, okay? So that's where your voltage comes in, right? So the number of rocks is like the current in an electrical circuit, okay? The more rocks you have, the more energy is going to be carried down that cliff. The bushes are like resistors in a circuit, limiting the electrical flow, okay? And the rocks basically go through the bushes on the side of the cliff, losing some energy as they go, and the energy is used up to crush the bushes, so to speak. I can't speak. All right. So if another thing to remember is that current, okay, is measured in amps. So again, current, this is measured in amps. It has an I here, but when we are talking about amps, and this will all make sense, IVR, it'll make so much more sense when we study Ohm's law. But current is measured in amps or amperes, and it uses the symbol A. Voltage is measured in V, and resistance is measured in ohms, okay? All right, moving on quick. I know, this is a quickie. Okay, so I am going to have to go ahead and continue this on another slide because as you can see here, or another recording because I'm running out of time. All right, so this will be part 1.